Assalamualaikum, my name is Muhammad Faizuddin bin Asmazi. Today we're going to do presentation about Practical Work 2. For introduction, computer-aided design is a technology that allows engineer, architect, and designer to create, modify, and optimize precise 2D and 3D model using specialized software. It helps improve design accuracy, reduce error, and increase efficiency in design process. Computer-aided manufacturing is the use of software and computer control machine to plan, manage, and automate manufacturing operation. Can improve production efficiency, ensure consistent quality, and support accurate machining of design part. The software we're gonna use is Inventor. Autodesk Inventor is 3D CAD software used for designing and modeling mechanical part and assemblies. It allows users to create 2D sketches, convert them into 3D model, and prepare drawing for manufacturing. So let's talk about procedure. First, CAD. The sketch was created based on given drawing using CAD sketch tool. Dimensions were followed according to the given measurement. The sketch shape was ensured to be complete and close. The sketch was prepared for the net process. Net is the revolution feature was used to create 3D model. The sketch profile was selected as shape, and the center axis was chosen as a rotation line. The model was revolved 360 degrees to form the solid part. Net is the chamfer feature was applied to all selected edge. The chamfer type was set to distance and angle. The distance was set to 2 mm to all part. Angle was set to 45 degree. Edge were modified to remove sharp corner. Net is the thread tool was applied to the outer surface. Thread type selected was ANSI metric M profile. Thread size used was M20 x 2.5. Thread class was set to 6G. Thread depth was set to 26 mm. Last but not least, the hole tool was used to create a center hole. Hole diameter was set to 6 mm. Hole depth was set to 30 mm. Drill point angle was set to 118 degree. This is the final result for the CAD. For next is I'm going to give it to my friend.
My name is Muhammad Zaidan Afiq Muhammad Zain. Metric number is 13DTP24F1021. CAM selected generate machine. Okay, for the CAM process, we first selected the CAM workspace to generate the machining toolpath for the model. After that, a new setup was created to define the machining reference and prepare the part of manufacturing. Since the component has a cylindrical geometry, the turning process was chosen as the suitable machining method. The model orientation was then properly adjusted to ensure correct alignment with machine axis. Okay, next, the work coordinate system or WCS was set at the select preference point to define machining origin. Finally, model was selected to proceed with toolpath generation for machine operation. Okay. For the next slide, for this step, we selected a general turning tool from the tool library. Specifically, the CNMT type insert was chosen to perform the face operation. The CNMT insert is suitable for turning operation because it provides a good cutting stability and surface finish. It mostly common used for roughing and semi-finishing process in lathe machine. In this case, the tool was selected to perform facing operation, which used to create a flat surface at the end of workpiece. To ensure that front surface is smooth and properly aligned for the next machine operation. For next slide, for this step, the profile roughing operation was implemented to remove the bulk material from workpiece. The same general turning tool used in previous facing operation was applied to maintain consistency in machine process. Profile roughing is important because it shapes overall geometry of the part by gradually removing excess material before the finishing stage. This helps reduce machine time and prepare component for more precise operation. The grooving option was adjusted from allow radial grooving to don't allow. This setting was selected to prevent roughing tool from entering narrow recess area. By doing this, we reduce the risk of tool interference and ensure safer and more controlled machine process. Next slide. Okay, for this step, turning grooving for the tool was selected from tool library to machine the external recess area or groove the workpiece. This type of tool is designed to cut precise groove on outer dimension of cylindrical component. To ensure compatibility with design specification, a tool with 10 mm diameter and 0.8 mm corner radius were chosen. Allow the tool to properly enter the groove area, and the radius help match the geometry define the design model. By selecting the correct tool, it is important so that we could achieve a correct dimension and maintain surface quality, but also prevent tool interference during grooving operation. Okay, next one. For this step, machine boundaries for groove operation were defined. This done by selecting the front and back reference faces on the workpiece. By specify the boundary, we control the exact region where grooving tool is allowed to cut, so that the tool only machine the intended recess area without affecting other part of the component. Define proper boundaries important to maintain dimensional accuracy and prevent overcutting. Also help improve tool path efficiency and ensure more precise and controlled grooving operation. Okay, the last slide for me. For the second groove operation, the machine boundaries were defined again to ensure precise cutting. In this case, the specific faces that form the larger rear undercut that was selected. By selecting these faces, the system clearly identified the exact region that need to be machined. Ensure grooving to remove material from intended undercut area without affecting any other surrounding geometry. Accurate boundaries for this second groove is important to maintain dimensional accuracy and achieve required shape at rare section of component. This complete grooving process before moving to the next machine operation.
My name is Muhammad Alif Imran bin Zainuddin. Matric number 13 DTP 24 F1006. Selecting the VNMT type insert. Specifically, VNMT 17302 right hand from the tool library to perform the chamfer operation on the workpiece edge. Next, selecting the VNMT left hand turning insert. VNMT 17302 from the library to perform chamfering on specific edge that require a left-hander tool orientation. Next, selecting the specific edge and contour on the workpiece to apply the chamfer tool path for final edge breaking. Lastly, selecting a 6 mm diameter drill tool from the library to create a center hole in the workpiece. Configuring the drill geometry with a 118-degree tip angle and a 60 mm flute length to ensure sufficient depth capability.
Video of this practical work.
Conclusion. This practical work was successfully completed using Autodesk Inventor CAD and CAM. The 3D model was accurately designed based on the given drawing, and alternate operations such as facing, profile, roughing, growing, chamfering, threading, and drilling were properly set up. The generated toolpath were simulated without any collision or error, and the G-code produced was suitable for CNC turning operation. Overall, this project demonstrates a good understanding of CAD/CAM concept, tool selection, and CNC machine process. Recommendation. It is recommended that future work include actual CNC machine execution after simulation to compare real machining results with CAM simulation. This will help improve understanding of machining accuracy, surface finish, and tool performance. In addition, optimizing cutting parameters such as feed rate and spindle speed could further enhance machining efficiency and tool life.